Okay, want to move now to section 2.6, part 1 video, section 2.6, part 1 video. And in this video, we're going to be looking, as a matter of fact, over the next 3 or 4 sections now. The next 3 or 4 sections we're going to be looking at, we're going to continue graphing, but we're going to graph some other functions. Now, we've done 2 types of graphs in this course so far together. The first type of graph that we've looked at was a circle. Now, the graph of a circle was not a function. Doesn't pass the vertical line test. Then we looked at graphing lines. Now, a line is a function, with one exception. All lines that we graphed in section 2.4, all of those graphs that we looked at were functions except a vertical line. The only type of line that is not a function is a vertical line because it fails the vertical line test. But all of the other lines were functions. What we're going to look at in the next multiple sections is we're going to look at the graphs of various other types of functions. In this next is section 2.6 that I want to look at with you. We're going to look at a special type of function called a piecewise function. That's the type of function that we're going to look at. Now, what I want to do first is I'm just going to barrel off into it, and I'm just going to show you, first of all, what a piecewise function, we've got to pass the vertical line test, piecewise function, just show you what a piecewise function looks like. What you're looking at right here is the graph of a piecewise function. Now, let me show you just a couple of things on why it's called piecewise and then why it's called a function. First of all, it's called piecewise because it has multiple pieces to it. Now remember, f of x is the same thing as y equal. So y equal or f of x equal same thing. All right, so this particular function has 2 different pieces to it. Now, what I want to do is I want to cover up all of this first. If this problem was just y equal 3x plus minus 2, let me say it a different way. Y equal mx plus b. If I covered up everything else and we just looked at that, it would be a straight line. Remember, a line is where x and y are both to the first power. So this is a y equal 3x minus 2 is a slanted line, is what that is. Well, what a piecewise function does is you don't look at the entire line, you only look at a piece of that line or a portion of that line. And what decides what portion of that line you look at is what comes after what I've got covered up right here. The stuff after the if that's written. And so that's what I want to look at. All right, so this problem has 2 different pieces to it. Now, what decides whether we're talking about the top piece or the bottom piece is what depends upon what x values you're looking at. Look at what comes after the if right here. If x is less than or equal to 2. Now look at what comes after this if statement. If x is bigger than 2. What do you notice about the statement that comes after this if and the statement that comes after this if? Do you notice that they represent an opposite set of numbers? For instance, if I said this, if I had a group of people that was, let's suppose I had a group of 100 people. And I said, okay, I want anybody in here, anybody in this group that is 79 years or older, or let's say 49 years or older, to stand up. All right, and then they stand up. And then I tell them to sit back down. And then I say this, okay, I want everybody that's in this room that is younger than 49 years old to stand up. You realize there's in those two groups, no one person would have stood up in both groups. You can't be 49 or older. You can't be in that group and also younger than 49. Well, if you'll notice, this says x is less than or equal to 2. That's all the numbers 2 and including 2 and smaller. But notice this says all the numbers bigger than 2. In a piecewise function, that's the way the pieces work. This piece and whatever this says, this uses the opposite of whatever's left here. That's what a piecewise function is. Now, a piecewise function could be 3 pieces or 4 pieces or 5 pieces. But in this particular case, I've only written one up that uses 2 pieces. Okay, so here's what I want to do. I want you to write this down, and then I'm going to ask you some questions. So write this down right here. Pause the video. Okay, I'm assuming you've got this copied. Now, here's what I want to do. We're not talking about graphing. Here's what I want us to do. I want us to find f of -1. F of -1. Now, have we done this before? Yes. As a matter of fact, your midterm exam has problems like this. This was some stuff that we did in that section 2.8. How do you find f of -1? You take -1 and plug it into the function where x is and work it out. Here's the dilemma. This function has 2 different pieces. So you're not going to take -1 and plug it into both pieces. Here's why. If you plug it into both pieces, you get 2 answers. So what does that mean? It means you picked one number for x, but you got 2 numbers for y. That means that one x is paired with this y, that one x is paired with this y. That can't happen with a function. In a function, no 2 ordered pairs can have the repeating x's. And by the way, that's why there's no repeating x's here with none here. These x's are just the opposite of this. So what you do is, depending on what x is, depends upon which one of these 2 pieces you plug it into. So, what are we letting x be in this problem? -1. Which one of these 2 pieces allows x to be -1? Well, question, is -1 bigger than 2? No. Is it smaller than 2? Yes. So since the number I'm choosing for x is in this range, I'm going to plug it into this part of the function. So you're going to take -1 and put it right here. When I do that, it would be 3 times -1 minus 2, which is -5. Okay, let's do another one. Let's do f of 0. Okay, f of 0, what does that mean? It means let x be 0. Well, which one of these pieces allows x to be 0? If you let x be 0, is 0 bigger than 2? It is not. Is 0 smaller than 2? Less than or equal to 2? Yes, it's less than 2. So 0 goes into this top piece again. So when you do that, it's 3 times 0, which is 0, minus 2, which is -2. Now let's plug in 2. So f of 2 means let x be 2. Well, which one of these pieces allows x to be 2? Well, if you let x be 2, is 2 bigger than 2? No. Is 2 less than or equal to 2? Yes. So this one still uses the top piece. So that would be 3 times 2 minus 2, which is 6 minus 2, which is 4. Okay, one more example. Let's do f of 4. So we're going to let x be 4 and work it out. Well, you're going to let x be 4 in the top piece or the bottom piece? Well, if you let x be 4, is 4 bigger than 2? Yes. So now you're putting 4 into the bottom piece. So when you do, you plug it right here in x's place, 4 squared plus 5, which is 21. So basically, if the number you're plugging in for x is 2 or smaller, so 2, 1, 0, -1, -2, -3, -4, etc., you're using the top piece. But if you're using numbers bigger than 2, 3, 4, 5, 6, 7, 8, 9, etc., you're using the bottom piece. All right. So now what we want to do is we want to talk about graphing the piecewise functions. Before I do that, I want to show you something that you do not have to copy. I just want to remind you of something. You don't have to write this down if you don't want to. This is a little bit of a review from intermediate. If I ask you to graph x is greater than or equal to 5, x is greater than or equal to 5, that would be all of the numbers 5 and bigger. So the way we show that is we start on 5 and go to the right. Now, in intermediate, what we do, if it says greater than or equal to, that means you're including the 5. The way we show that typically on a number line is putting a bracket on the 5 going to the right. Now, another common way to do that is to put a dot on the 5 and draw to the right. Either one of those is fine. Now, what is the difference in the graph x is greater than or equal to 5 and x is just greater than 5? The difference is this is all the numbers greater than or equal to 5, so you're including 5 in your graph. The difference here is you're not including 5. It's all the numbers bigger than 5, but not 5. Now, here's where the mistake students make sometimes is. What they'll do is they'll say, okay, if you're going to show a graph all the numbers bigger than 5, start the graph at 6. That is not correct. Why? Because if you start your graph at 6, aren't we leaving out numbers between 5 and 6? See, if I ask you, are you older than 5? Really, if you're 5 years and 2 months old, you're really older than 5 years. You don't have to be 6 to be older than 5. You can be 5.5 years old. So you don't start your graph at 6. Well, what do we do then? What we do is we still start the graph at 5, just like you do up here, so that you can include the fractions. The difference is we can't use the 5 here, but we can here. The way we indicated that in intermediate is by putting a parenthesis on 5. So the equal to, you use it. The no equal to, you don't. And the way we show that's with the parentheses. Or you could put an open dot. A lot of teachers teach it that way. That's fine too. A little open dot going to the right. Here's the main thing I want you to see. X greater than or equal to 5, the graph starts where? At 5. X greater than 5, the graph starts where? At 5. So both of these, the graphs, start at 5. So if I use that same reasoning, if I ask you x is less than or equal to 7, where would the graph start? At 7. X is less than 7. Where would the graph start? At 7. X greater than 3. Where would the graph start? At 3. But here's the difference. In this one right here, because of the equal to, you're going to include the 7. So that means you'll have a bracket or a closed dot. But here there's no equal to, so it's going to be open. Here there's no equal to, so it's going to be open. So when you go to graph those, your graph would be on 7 with a closed dot, on 7 with an open dot, on 3 with an open dot. All right, I'm going to use that in what I'm about to show you. Let me tell you one other thing right here. Be sure you listen to this carefully. A couple of years ago, we used to, a lot of students on the piecewise functions, they had a lot of trouble graphing the piecewise functions on the computer because it was so technical, and you mess up with one little part and it'd make you start all over. So here's what we did. We took them off for a while, and then we put them back on. But when we put them back on, students was having so much trouble with it on the computer. Not freehanding it, but they was having so much trouble on the computer drawing the piecewise functions. And so what we finally did was we started making the graphs on the computer that you have to do in this section multiple choice. Be sure you listen to this carefully. You still have homeworks on piecewise functions on graphs that are multiple choice. You pick the graph that works. But what I want you to understand is when you go to take, when it comes time for the test, and it comes time for you to do these in the classroom, I want you to do them the way that I'm about to show you. I want you to put in all the work, because it's not going to be multiple choice when you take the test in class. So I would suggest, even when you do the ones on your homework, even though they're multiple choice, I would strongly suggest that you do the problems the way that I'm about to show you on graphing piecewise functions. So what we're going to do in the very next section is or in the very next video, I will show you how to graph the problems of piecewise functions from ground zero. I'll show you how to do that. So make sure you write down these next two examples and put them in your notes.